Good morning, ladies and gentlemen. Do this now in your notebook. Miss Moore has a mass of 65 kilograms. How much does she weigh in newtons?
What is weight? I think this has something to do with Newton's second law.
It does. Has a mass of 65 kilograms. How much does she weigh in newtons? Okay. Well, what was the acceleration due to gravity?
Well, it's negative 9.80 meters per second.
Okay. Let's go ahead and plug this into our calculator.
Should be about 63 something, 630 or 600.
65 times a negative 9.8, and we get
637.
637
What does that negative mean?
newtons. Yeah, there's a negative right there. What does that mean? Well, the negative is just the direction, right?
That's all it is.
So it's 637 newtons, and it's
Down.
down, right?
Sweet.
Okay. Oops, wrong way. Okay. If you hit a wall.
Do that again. Boom! Deliver a whooping to the wall.
If you hit a wall delivering 600 newtons of force, how much force does the wall exert on your hand? What's the,
That's one of those laws, isn't it?
I think it's the third law, Newton's third law,
I think it's
right?
the Newton's third law. What does the Newton's third law say, boys and girls? Can you touch something without it touching you?
Forces come in pairs,
That's
right?
it. That's
And
it.
so if I'm delivering, if I am hitting the wall with 600 newtons of force,
Boom!
that means that the wall is exerting 600 newtons of force onto my hand as well. Now, Boykin, do we have to do any sort of negative sign in front of this, or I mean, it's just the opposite?
Equal magnitude, opposite direction. You can put equals in. You delivering a whooping to the wall. The wall is delivering a whooping on your hand.
Right? Hand, wall. I mean, they're equal. That's the whole point, right? But opposite in direction. So
You-
put a
yeah,
negative
put
on
a
one of
negative
them.
in one
Put
of
a
them.
negative on one of them. Yeah.
can't
We'll
really-
go here.
All right.
You decide. Okay. Force net has two meanings: the net force, the sum of the forces, and that is the first definition. Force net is the sum of all forces acting on an object. So if you want to know the net force, you have to do this force plus that force plus that force.
And forces are vectors. Sometimes you have to do vector addition.
We'll be okay. All right. Draw a free body diagram of a 0.5 kilogram cart as you push with 2 newtons of force, causing an acceleration of 3 meters per second. Free body diagram.
Free body diagram. That starts with a dot, doesn't it?
Dot. If you don't know what to do, start with a dot. It's a good place to start. Okay. So free body diagram of a 0.5 kilogram cart. So mass is 0.5 kilograms.
You're pushing with 2 newtons. You can make that to the right.
Yeah, we'll push it that way. Now, does it matter if it went the other way?
Doesn't matter. You can call it
No. 2 newtons?
2.0.
What is
And
it?
it's got an acceleration.
Ooh, that's important. Okay, my acceleration equals 3.0 meters per second squared, and it's going to be that way.
Yep.
We're pushing it's going that way.
Okay, now there's some other things we can put in here, can't we?
Well, is our dot, what is it again? Our cart. Is our cart falling? Is our cart falling? Woo! No. Right, so we have the force of gravity this way, right here, keeping it from falling. And our force of gravity, that's mass times acceleration, right?
Yeah.
And we have our mass, right?
0.5, so it'd be 0.5 times 9.80. The half of 9.8 is 4.8 something? 4.9?
Should I put it in the calculator, or are we confident here?
Yeah, put it in the
I feel like
calculator.
we need to put it in the calculator. We're never too good for a calculator. Negative 9.8, and I get negative 4.9.
4.9, I was right. I said 4.8, that would have been wrong. What other force can we put in here?
Okay, well, is the cart flying up?
It is not.
It's not. So we are going to, so equal in size, opposite in direction. That is a little crooked, but we're gonna go
Fup.
force up, the fup.
Fup.
And, well, it's equal in size, opposite in direction, so it's gonna be 4.9 newtons.
Yep. All right, so we have completed the task. What's next?
Moving on. Our second definition of for force net. Force net produces an acceleration on a mass. Force net equals mass times acceleration. So we can add up all the forces, or we can use this equation right here. What is the force of friction on the cart while you are pushing?
Uh-oh. We need to know the net force. How can we get the net force?
How can we find the net force? Well, we can find the net force by
That's
adding
mass.
up the forces, right?
Well, it's mass times acceleration. We could, but we don't know what friction
We
is.
don't know what friction is.
So we've got the mass. Do we have the acceleration?
We do. So force net equals my mass, which is 2.5 kilograms, times 3.0 meters per second
And
squared.
half of 3 is?
1.5?
I think so.
We don't need to calculate that one. Okay, so what is the force? Oh, so what is the force
So
of friction on the
put the
car?
net force in. Put the net force arrow in somewhere.
It's going to be equal to 1.5 newtons, and it's going to be the same direction as the acceleration.
So now, how can we find the force of friction? We didn't put that on there.
Well,
What is
I'm running a little
friction?
space here. These two cancel out. The force of friction is going to go the opposite direction of the motion,
Yeah.
right?
Yes.
So it's going to go this way.
Yeah.
These cancel out. It's 1.5. Sorry, it's 2. It's the total net force is going to be 1.5.
So 2 plus what equals 1.5?
Okay, so
Is that making sense? The net force is 1.5. That's the sum when you add everything up.
this is what we're looking at.
So 2 plus what is 1.5?
Our
Oh, I like
force
that.
one,
I like that a lot.
1.5 newtons equals force 1 is, well, this is the one we're trying to find, we'll say, plus 2
2.0.
newtons, and this is going to be our force of friction that we're trying to find. We can just subtract this, right?
Yep.
Minus 2 newtons. That's going to be negative 0.5, right?
Yeah.
Equals the force of friction.
So now we got the force of friction.
Okay, so negative 0.5 newtons.
It's the force of friction.
Okay, so to recap here, we drew our free body diagram,
Yep.
and we were given our acceleration, we were given the force of the push, and we knew that this was 4.9 newtons because it's equal and opposite to this.
Yep.
We calculated this using our mass times acceleration.
Yep.
Then it said, what is the force of friction? And we know that there's two definitions for in order to find the net force. We have F equals M times A, and we have this one over here that we use later.
Those are the two things that net force means.
So in order to figure out what the net force on this is going to be, we said, okay, we have the mass times the acceleration. This is what the net force should be. So we can plug that in for this net force.
Put it into the sum.
Subtract this over here and get our force of friction. And it gives me a lot of confidence that the answer is negative because we know it's going to be opposite. It should be negative because this is the
Is
negative
this making
direction.
sense, boys and girls? Are we firing over your head?
Hopefully.
No, hopefully not.
Hopefully it's making sense. Sorry.
That's right.
Okay. Draw a free body diagram of the cart while it is coasting.
I think we've already done this.
We have already done this. Do we need to do this again?
Oh, no. While
What
it's
is it?
coasting. No. Well,
Oh, well, right
okay,
now
if
being
it's coasting,
pushed.
you're not pushing on it.
Yeah.
Don't erase anything.
I know. So what
What
are we
can-
going to change?
What can we take out? Well, you're not pushing on it anymore.
Okay, so we can take this one out, right?
Yeah. And the acceleration is not going to be 3 meters per second to the right. You can take that out.
What else?
You can take the force of the push out.
This is gone
And the net force is no longer forward.
because we're not pushing it, right?
Yeah.
In
So
fact,
let's
it's
take a
slowing
look
down.
Let's take a look at what we've got.
It's slowing down, right? It's coasting, coming to a stop. So that
It's
means our net
slowing
force is
down.
going to be backward because my acceleration is which way?
And how can we know what that net force is? Well, it's the sum, right?
So
Any
we
ideas?
still have our net force. Our sum is still 1.5 newtons, right?
No.
This times this. Oh no, we don't have that anymore,
No,
right?
you can take that out too.
No, we don't have it.
In fact, you can erase that sum down there because
Is this here?
there's only one force that's not canceled out.
Oh yeah. Let's go back to our question. It says, what is the net force? What is the acceleration? So
So it's coasting
it's just coasting. Our net force is just going to be.
half a newton.
Because
Because the force of friction is not going to change.
So why was that different than before, though? Because before we had to do that whole calculation thing, right?
Well, we had different information. We had to do
Yeah.
some analysis and reasoning.
Yeah. Before we were pushing it, it was experiencing a push force and a friction force. We
Yeah.
had to do that math, right? Right now we're no longer pushing it. We just have this one pointing back.
That's an excellent point. I
Okay.
like that.
And what is my acceleration right now? Well, let's go back to our equation. We want to know this acceleration right here. Can I just get rid of this?
We got the net force. We've got the mass.
Okay, our force net is negative 0.5 newtons divided by 0.5 kilograms. That means that we're just going to have a negative 1 meters per second squared, right?
I like that.
Sweet.
So that's the acceleration. Guys, see how that? See, a free body diagram is a powerful device.
And we just had to tweak a few things based off of what we had up here. And we know what's really important is we know that because it's coasting, it's slowing down. And that means that my acceleration is going to be this way. My net force is going to be that way.
Yep.
Okay.
Sweet.
What is the weight of a person with a mass of 65 kilograms?
Sounds awfully familiar to me.
Should
Didn't
we do this
that?
and then the video?
I think that, well, first of all, let the boys and girls find this, and then let's watch the video. So,
So go ahead and do this real quick. What is the weight?
seems like it wasn't it 635 newtons, 640 something. 9.8 is just a little bit less than 10.
Should I do this on the board or
65
should we
times.
talk about it, Boykin?
Pardon?
Should I do it on the board or should we talk about it?
Well, that was the do now.
It was the do now, right?
Yeah, come on.
So I'm not going to do it again because you already did it before. What is the weight of a 65 kilogram person? Look at your do now. 65 kilograms times a negative 9.8, and that was
Yeah.
what? 60?
Now we went to video. Video. Video.
Here
Video.
we go. Here we go. All right, I'm ready.
Full size.
Full size, baby. Volume is.
Hit it.
Could be a little better. Hold on. And here we go.
We be rocking out now. What the? Wow! What the? It's witchcraft!
That looks like fun. Birthday parties! Oh my god! Corporate parties!
Yay!
Team building. That stuff's not important. What's going on here?
They're in like a wind tunnel. Education. See, there's the bottom and there's the top of the wind tunnel.
How come they don't fall? Like, all
Because
the
wind
way
is
to the
blowing
ground?
up in that direction.
Ah.
And it comes in at the bottom like that. There's a guy that can control it.
Team on three. 1, 2, 3.
Whoa!
I've never done that before.
Not me either. Even little children can do it. I want to 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 do it.
And they have food too.
And stuff. And balloons. Whoa. That's cool.
All right, here. I'm gonna pause this.
I fly.
I fly. Go check it out, kids. Okay. All right. So the 65 kilogram person, this more, steps into the I-Fly wind tunnel and floats in one spot. Draw a free body diagram with all of the forces. Force, net, and acceleration.
Well, let's start with a dot.
Start with a dot. Okay. So let's go ahead and draw the dot. Me. Because I'm a 65 kilogram person. And the first thing I'm going to do is the force of gravity.
That's 637 newtons. We got that earlier. 637 newtons.
Thank you. I was like, what was that?
Yeah,
And if you
I just
forgot-
cheated. I just did it again.
And if you forgot, it's just 65 times negative 9.8 meters per second.
They
squared.
haven't forgotten.
You better not forgotten. Okay, what else? Have you ever stuck your hand outside of the car while it's driving?
That's
Like-
such a fun thing to do.
And when you go like this, it's like, whoa! When you go like this, you can like, up and down.
And if the car's not going very fast, it doesn't work.
Then nothing happens, right? And what are we experiencing what kind of resistance are we experiencing?
Air resistance.
Air resistance. So, the fuck, we're gonna give a specific
If the
name.
person is floating at one spot, what's their acceleration?
Ooh, I'm gonna put a negative here.
I like that.
637 newtons. Ask that question again.
What if they're sitting in one spot or sitting and floating in one spot? What's their acceleration?
It's kind of like me sitting right here, right?
You're not accelerating.
So acceleration is gonna be
And according to the Newton's second law, if the acceleration is zero, what's the net force?
force net is 0, right?
It means the up cancels out the down, yeah?
Yeah, these are canceled, right? Okay. So
That's simple.
free body diagram forces. Okay, let's do it. Moving on. The operator turns up the fan and the person accelerates upward at 1.5 meters per second.
What would we have to change on our free body diagram? We could just make another one.
So, oh yeah, that's a good idea. I'm gonna go ahead and do it over here.
All right.
Okay, so dot.
What's going to be the same?
What will be the same?
637 newtons. But if they're accelerating upward at 1.5 meters, that means they turn the fan up. That means the force of the air has got to be mo, right?
Mm-hmm.
We don't know how much mo.
So how do we figure this out?
Well,
Mass times acceleration.
there's 65 kilograms, right?
So force net equals mass times acceleration. So 65 kilograms times 1.5 meters per second squared. So I'm just getting the
About 90
net,
something, isn't it?
net force. 65 times 1.5. 65 times 1.5, and I get 67.5.
Oh, close.
Oh, wait, sorry, 97.5
97.5.
newtons. And so we're based off of our mass and the acceleration from the wind.
So
We have
the
our
net,
net force,
and that's going to be up, right?
and that's going to be up. So net force is up, and it's this. So how can we figure out what the top's going to be again?
Well,
The
we've
force
already
of the-
used the part of net force where it gets the mass times acceleration. What was that other thing that net force means?
Well, it also means force net, Miss Moore, also equals force 1 plus force 2. And in this case, we have, well, it's going to just be equal to these two, right?
Yep.
The force, the gravity.
So the net force is 97.5.
Oh, yeah, let me just put that in right now, actually. So force net is net, because I'm running out of space, 9.5 newtons equals, and force 1 we can call this, which is negative
Negative 637.
newtons,
Plus
plus
force of the air.
force of the air.
Fair.
Okay, force 1 and force 2, force 1 and force 2.
How can we solve for the force of the air?
Let's add this over here. Plus 637 newtons. 637 plus that. So plus 637. And it is 730. I'm just going to call it 735.
That makes sense to me.
Can you guys still see this?
We'll put it up there on the top. Yeah, you can see.
Oh, yeah, you're right. So this is going to equal the force of the air. And I'll write it up here for you guys, too. We got 735.
So what do we just do? The fan operator turns up the fan and the person accelerates upward at 1.5 meters per second. Just having that one little piece of information allowed us to find out how hard the wind was blowing.
Mm-hmm. And we know also the net force should be this way. What do you notice about this arrow? It's longer than this one,
Yep,
right?
yep.
Because there's more force. Okay.
Sweet.
And let's see. Aha. The operator turns down the fan and the person accelerates downward.
We have room for another dot?
At that one. Oh yeah. Oh yeah. Here we go. Okay, what should be the same?
Force of gravity.
Force of gravity, easy. Force of gravity equals 637 newtons negative.
Yeah.
And then my acceleration is
Down at negative 0.75 meters per second squared. So is that arrow up going to be longer, shorter, or the same length as the force of gravity?
well, I know my net. Okay, so my net force is going to be down, which means that my top arrow is going to be shorter now.
So we have to do the same thing. What did we do before in order to find that? So all the stuff written down. Oh, I think we did that first, right?
Yeah, we did. We calculated the net force.
Because we got the mass at 65 kilograms.
We said we use this equation right here. Force net equals mass times acceleration. Our mass, well, it's
65 kilograms.
What's our acceleration now, though? It's gonna
Negative 0.75.
Okay. So our force net's going to be 65 times the negative.
You're on 450, 480, something like that.
9.75. Negative.
48. We'll call it negative 49
Okay, I like it. Negative 49.
newtons. So that
Okay.
net force is down.
Negative 49. And over here, our net force was 97.5. So we have a difference there. What do we do next?
Well, we got to use the other definition of the net force, which is the sum.
Mm-hmm. And what are our two sums here? We've got force
Well,
of gravity,
the
force
net
of
force
air
is negative 49.
equals
Force
Force.
of gravity, that hadn't changed. That's also negative
negative
637.
newtons plus
What we don't know yet.
force of the air. Okay, I'm going to add this over here. Cancels out. Plus 637 newtons.
That's going to be 600. No. I can't do that in my head. That's going to be 500 something.
637 minus 49. And I get a 588.
588 newtons.
588 newtons equals the force of the ayo.
So the force of the air is 588.
Equals 588. Now, does this answer make sense? This should be less than this. 588 is less than 637. So we're good.
Yep.
Okay.
All right. Let's watch a Eureka.
Eureka. Okay, so pause the video and go to the video right below this one and watch this, please.
I'm going to stop it.